Hello and welcome back to Maysie's Algebra Initiative. Today we're going to go over some Unit 4 topics. This involves slope, arithmetic sequences, going over x and y intercepts, and then learning about the three forms that a linear equation can take, which is point slope, slope intercept, and standard form. Let's get started. Okay, so we're going to start off with slope, and it's basically the growth on a graph or like a linear line, like how much it grows or how much it decays. Now, we define slope as the rise over the run. You can kind of think of this as like you have to, if you have a tree, you got to go up the tree and there's a branch on that tree. And let's say you like lost your cat up here. To get to your cat, that's a cat. To get to your cat, you must go up the tree before you can go across the branch. Rise over run. And that's a fun little way I like to remember it. To get your cat out of the tree, that's how you remember it's rise over run. So you must go up before you go across. And there's an equation for slope. And that's y2 minus y1 over x2 minus x of 1. And basically when I just have the 1s and the 2s next to the x and the y's, that just means they belong together, like they're points together, like this. And usually the variable we use for slope is m. And if you notice, y sub 2 minus y sub 1, that indicates the vertical axis, that's rise, over x sub 2 minus x sub 1, which is the horizontal axis, which is run. Okay, here's some examples to find slope. You can either count it out on a graph or you can use the slope equation between 2 points. Now, to do it on a graph, I will first pick out 2 points on the graph. So I'm going to go here and here. And I'm first going to count up, then over, rise over run. So I'm going up 1, 2. I'm going over 1, 2. So the slope is 2 over 2, rise over run, and that equals to 1. Now let's see how it is between these 2 points. We have this is x sub 1, y sub 1, x sub 2, y sub 2. So let's just I'm going to write out my slope equation. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's going to equal to, let's plug it in. So we're going to have 4 minus 2 over 2 minus 0. 4 minus 2 is 2. 2 minus 0 is 2. And that is equal to 1. So they have the same slope. Now, there is such thing as negative and positive slope. All the examples we have used so far are examples of positive slope. Now, if you read the graph from left to right like you read a sheet of paper, you can notice that a negative graph will go down as you go left to right, and a positive line with positive slope will go up. See, the negative slope goes down as I go left to right, and then as I go left to right on this one, it goes up. Now, if I count out the slopes, I would realize the same thing. So I choose 2 points, and I go down 1, so minus 1 over 1. So it would be negative 1 over 1, and that would be negative 1 slope. And then here I choose 2 points, up 1 over 1. That's 1 over 1, rise over run, and the slope of positive 1. Now let's practice. Find the slope of both the questions. Pause the video to solve it on your own, and then unpause the video to get the answers. Okay, pause the video now. Okay, so here are the answers. So number 1 involved using the slope equation to find the slope. So I wrote my slope equation, and I plugged in the points given, and I ended up getting 2 as my slope when I simplified. And the second question involved using a graph and counting out the rise and the run to find the slope. And so I counted up 3 over 1, and it's positive slope going left to right. So it's going to be a positive 3. Okay, next on today's list is arithmetic sequences. An arithmetic sequence is a series of terms that increase or decrease by a constant amount, and I'll show you what I mean. From 1 to 3, that's just adding 2. From 3 to 5, that's just adding 2. 5 to 7, adding 2. 7 to 9, adding 2. See how I just increase by a constant amount? So that's called our constant difference. And in this case, it is 2. Now, let's look at the next one. So we have 2 and 4. How do I get to 2 for 4? I add 2. 4 to 8, I add 4. And 8 to 16, I add 8. This is not an arithmetic sequence because it does not increase by the same amount each time. This is actually a geometric sequence, but you'll learn that later on. So not an arithmetic sequence does not increase by a constant amount. Okay, let's check this next one. 3 to 7 plus 4, 7 to 11 plus 4. And if you ever want to figure this out, you can just do 11 minus 7. Recognize that's a difference of 4. 11 to 15, that's plus 4. So this is an arithmetic sequence, and its common difference is positive 4. Because I'm going up by 4 each time. Now, we use a special equation for the arithmetic sequence, and it's this. I have a of n equals a of 1 plus n minus 1 times d. A of n is the term you wish to find, term, nth term. A of 1 is the first term in the sequence. N is the number term you wish to find. And then D is the common difference. This is super important. I should see this is bam, this is so important. Woo! You'll be using this a lot. And these are what each individual term means. Now let's see how this is applied. Now, this is usually applied when I want to find a really high numbered term. And I know that I could probably just add the common difference over and over and over again until I got to that term, but sometimes the numbers are too high to do that. So here I have a sequence. So my first step is going to be to find the common difference. Make sure it's an arithmetic sequence. I'm going to do CD for common difference. So from 10 to 13 is positive 3. 13 to 16, that's positive 3. Positive 3, and positive 3. Each increase by positive 3, so my common difference is going to be positive 3. Now, my next step is to write my arithmetic equation. EQ2TN is just an abbreviation for equation. So I have A of n is equal to A of 1 times plus n minus 1 times common difference. See, it's the same equation we used here. Okay, now let's plug in what we know. So A of n, we don't know what that term is. That's the term we're trying to find. A of 1, the first term is 10. So we got 10 plus, what's n? The 103rd term, minus 1 times our common difference of 3. Now, this is equal to a of n. Or, in this case, we can just write a to the 1/3 Now, when I solve this out, I get 316 because, and that's our next step, it was to solve. And the way to check this work is just to redo the problems and just redo them to make sure you didn't make any simple errors, because sometimes just redoing the problem will help you catch some things. And solve it out, I get 316. That will be the 103rd term of this arithmetic sequence. Okay, here's some practice. Now, pause the video now so you can work these out, and then unpause the video for the answers. Pause now. Okay, so here's the answers I got. For number 1, I have, no, it's not an arithmetic sequence because it does not have a common difference. It doesn't increase or decrease by a single number. It's various numbers. It's not the same. For number 2, it is an arithmetic sequence because it increases steadily by 5, so that is a common difference. And number 3 is decreasing steadily by 3, so my common difference is -3, but it is also an arithmetic sequence. Now, okay, we are going to find the 111th term for each sequence. This is another practice section, so once again, pause the video and unpause the video for the answers. Pause now. Okay, so here's the answers. I plugged in all my information into the lovely arithmetic equation, and this is what I got. I also found the common difference before finding all these. Okay, next topic is x and y intercepts. The x-intercept is when a line crosses the x-axis and its coordinate point's going to look like a number, 0. While a y-intercept is when the line crosses the y-axis and it is usually labeled as on a coordinate point 0, a number. I just put y in there. And this is my x. This is my x-axis. This is my y-axis. Okie dokie. Now, there's 3 ways we can identify a x or y intercept. 1, on a table, 2, on a graph, or 3, from an equation. On a table, the x-intercept will be the value on the chart across from the 0 y value, and the y-intercept will be across from the 0 x value. So the x-intercept in this case is going to be across from the 0 y value. It's going to be 2, 0. So the x-intercept is 2. And then for y, across from the 0 x is going to be 1. So it's going to be 0, 1. And that's it in coordinate form, but if you just want to write the y-intercept, it's as a single entity, it's 1. Now, let's look on a graph. All you have to do in this case is look where the line crosses the x and y axes. Let's look at the x-axis first. So it crosses at 1, 2. It crosses at x equals 2. So the x-intercept is going to happen at 2, 0. Or we can just say 2. That's the x-intercept. Depends what your teacher asks you. And now let's go to the y-intercept. 1, 2, 3. It crosses at y equals 3. So we're going to have 0, 3 if it's in coordinate point form, or just 3. From an equation. This is the hardest of the 3. You plug in a 0 for y to solve for the x-intercept, and you plug in 0 for x to solve for the y in the y-intercept. So let's start with the x-intercept. Plug in a 0 for y. We solve it out. X is equal to -3. So the point's going to be -3, 0. And now let's do the y. We make x 0. and y just turns out to be 3, so the y-intercept is going to be 0, 3. Okay. Here's some practice. Using the following, determine the x and y intercepts. Pause the video now to solve out your answers, and then unpause the video to check if you got them right. Okay, here's the answers I got. For number 1, I got the x-intercept to be 1, so the point would be 1, 0. For y, the x-intercept was also 1, so the point would be 0, 1. And you determine this by just counting out on the graph. For number 2, for the x, I determined the value across from the 0 in the y column of the chart, and that turned out to be 2. So 2 is the x-intercept, and in coordinate point form, it's going to be 2, 0. And the value across from 0 in the x column would be 7 for the y-intercept. So it would be 0, 7. And that is the coordinate point, and the y-intercept would be 7. Okay. Next, we have linear slope equations. This is the last thing we're doing in this video. There's 3 major equations you will learn in algebra this year. Number 1, slope-intercept form. This is the most common. Y equals mx plus b. Ingrain it in your brain because, trust me, this equation will become your best friend. Okay, let's break it down. So y and x just basically stand for a coordinate point on the line. And the m stands for the slope, and the b is the y-intercept. Ooh. It's the most common, and you write this equation when you are given a point and a slope, henceforth the name point-slope form. The next type you use is, slope-intercept form, my bad. The next one is when you have a point and a slope, and that's point-slope form, and that's y sub 2 minus y sub 1 equals m, x sub 2 minus x sub 1. Remember, the sub 1s and the sub 2s just determine what y value the x value matches up with, or vice versa. They're just points, and m is the slope. I need to change this up here, folks. That's supposed to say when you have a slope and the thing. Fun times. Yes, and the point-slope form is when you are given a point and the slope. Standard form is the least common, and it shows up every once in a while. It's not nearly as common as the other two. Just know what it is. It's a of x plus b of y is equal to c. And it's usually just used to turn into one of the other two, or vice versa. Okay, switching from one form to another. This is going to be a big bulk of what you're going to do with these equations. You're going to be given information that will, per se, let me say I'm giving a slope and the y-intercept. That means I have enough information to make the slope-intercept form of the equation, but they're asking me for the point-slope form. I would have to manipulate the slope-intercept form to get to point-slope form, and you're going to get a lot of questions about that. That might sound confusing right now, but let me just show you what's up. So here's an example of going from slope-intercept to standard. They want standard form, and I have slope-intercept form. So I just switched it around to look like standard. So I started in y equals mx plus b. I just move it around till it looks like ax plus by is equal to c. The variables don't really have to line up as long as x and y's are in the same place. You notice how these resemble each other? All I had to do was move the x to the other side, and that's that. It's all simple algebra manipulations. Okay, here's an example of what I was talking about earlier. I'm given a point and a slope. And that means, I'm getting a point and a slope, and they want it in slope-intercept form. Now, step 1 here is to make it a point-slope equation because we are giving a point and a slope. And step 2 is manipulate it to make it look like a slope-intercept equation. So first I distributed the 3 to the x and the negative 1 because there is no parentheses in point-slope form, and I need to get the x, I need to get it distributed out. So I want the y all by itself, so I take this 2 and I add it to both sides, which eliminates it here, and it adds it to this side. And now I have an equation that looks like y equals mx plus b, correct? Y equals 3, aka mx plus b, and it's minus 1 because b is negative 1, and that changes the positive sign. Okay. Here's some practice. I've given you some equations, and now some are in point slope, some are in slope intercept, and some are in standard, and now you have to switch it to another version. Okay. I'm going to pause the video so you can solve this out, and then unpause the video when you wish to see the answers. Pause the video now. Okay, here's the answers I got. Right here we have, I just manipulated the equation so it kind of looked like y equals mx plus b, which it does. And number 2, I did the same except for going to standard form. And same with part 3. I used simple algebra, adding and subtracting to both sides, multiplying and dividing to both sides of the equation. And that's all it is. And if it's helpful to you, you can kind of write out the equation to the side and make sure it mirrors it. But other than that, that's all there is to it. Thank you so much for watching. I hope you learned something new today. And if you have any questions or comments, just comment below. This has been Maysie Calzone from Maysie's Algebra Initiative, signing off.